So let's take a look at some concrete ways to change from improper fractions to mixed numbers, and then also mixed numbers back to improper fractions. So let's start off with, so we're going to use the hexagon to be a whole, right? So I have halves, I have thirds, and I have sixths here. So in my piles, I have 10 of these things that I call halves, right? 10 halves in that pile. Then I have 7 of these things that I call thirds in this pile. And then 13 of these things that I call sixths. And so what I do to make these improper fractions into mixed numbers is I start making wholes, and I look at how many wholes can I make. All right, so I have 10 of these things that I call halves. And so what I'm doing is saying, well, how many groups of 2 can I make out of 10? How many groups of 2 can I make out of 10? So I am taking 10 things and I'm putting them in groups of 2 and I'm counting the groups. All right, we should recognize that as the measurement subtractive concept of division. Okay, so I just measured off 2, measured off 2, measured off 2, and that is an equivalent to doing 10 divided by 2 and getting 5. All right, so let's use the same idea here with 7 of these things that I call thirds. I'm going to start with 7, and then I'm going to measure off 3, and then I'm going to measure off 3, and I'm going to see how many times I can measure off 3, and then I'm going to look at what's left. Okay, so that is equivalent to doing 7 divided by 3. Right, so I can see over here, I can measure off 3. So there's one of my holes. Measure off 3, so there's another hole. And then I'm left with 1. Well, how do I describe the piece that I'm left with? Okay, so when I do this, and I'm left with 1, well, I'm left with 1, but it's 1/3, right? Each piece is a third. Okay, so let's try that same idea with 13 of these pieces called sixths. I want to know how many times can I measure off 6, measure off 6, right? And then what am I left with? So each group of 6 makes a whole. Right, and then I'm left with 1 of these things that I call a sixth. Okay. Now let's go the other way. Let's look at 4 2/3, and I want to make this into an improper fraction. And you know how I'm a big fan of the what-y chart. Right, so we're going to make a what-y chart for this. And cute little sayings that you've probably heard of, like I've heard it called around the world, right? Where you multiply this by this, and then you add in the 2, right? And they call it around the world. Don't forget to go around the world, okay? But let's look at the what and the why of all of this. So let me put some of these things out of my workspace. Get these out of the way. And bring in 4 2/3. Okay, so the first thing that we tell students to do when they're changing 4 2/3 into an improper fraction, first thing we tell them to do, so here's my what and here's my why, we tell students to multiply 4 times 3 to get 12. Right, so where do I see 4 times 3 here? Each of these holes is made up of 3 thirds. Oh, sorry. Right, each one of these holes is made up of 3 thirds. Okay, so I'm not going to take the time to put these pieces onto every single one, but clearly you can see that if I looked at my wholes, if I decided to take my pies and cut them up into 3 pieces each, right, then I would have 3 times 4 of them. Okay, so on the y side, I am going to say you have 4 whole pies cut into 3 pieces. Cut into 3 pieces each. And this accounts for 12 pieces. Okay, the next thing we tell students to do is after they do 3 times 4, add in the 2. Okay, so why am I doing that? I have these 12 pieces here. So imagine I have 12 blue pieces in front of me now instead of the yellow pieces. I have 12 blues, but then I already had the 2/3 sitting there. Okay, so what I'm doing in step 2, when I do 12 plus 2, what I'm doing is I account for, it accounts for the pieces in the non-whole pie. Okay, and then I have 14. Right? I have 14 blue pieces. Right? Why do I have 14 blue pieces? Well, 14 pieces of pie are present. Okay, but my answer is not 14. My answer is 14/3 is the final answer. Okay, so why is that? Right? Each pie is 1/3 of a whole pie. And you have 14 such